Welcome to the notes on using the fundamental identities to evaluate and factor. We're going to start by evaluating using trigonometric identities. So in your notes, we're on this section. So just to go over what it says first, given values of a trigonometric function, you can evaluate other trigonometric functions. In other words, if you know like sine and cosine, you could find tangent or cotangent. And that'll give you a few basic instructions. First, I always recommend drawing the right triangle on the unit circle, labeling the known information. Note, do not label tangent or cotangent. That actually hinders your progress, unless it's your only option. 2, find the missing side on the right triangle, which usually is your hypotenuse. Use the trig identities to find the 6 other functions. So I'm going to give you an example over here. Find the 6 trig values, and this is what I know, the secant and the tangent. So secant goes to cosine, so therefore I automatically know the cosine is negative 2/3, the reciprocal. And I know the tangent is greater than 0. Remember, tangent is sine over cosine, and this is a positive value. So I need a location where the cosine is negative and the sine is negative, because a negative divided by a negative will give me a positive. That location is going to be in the lower left quadrant, which is the 3rd quadrant, because here the cosine is negative and the sine is negative. So this side is negative 2, this side is 3. I have labeled the sides on my triangle. Now I'm going to find the missing side. Negative 2 squared plus b squared equals 3 squared. B squared plus 4 equals 9. So b equals the square root of 5. I subtract 4 from both sides, got 5, square root. This is a negative root 5 due to its location. From here, I can find the sine value. Sine is going to be opposite over hypotenuse, so it's going to be negative root 5 over 3. The cosecant will then be negative 3 over root 5, in which I need to rationalize. So I end up with negative 3 root 5 over 5. The tangent is going to be the opposite over the adjacent, which is going to be negative root 5 over 2. And finally, running out of room, the cotangent will be negative 2. Oops, sorry, this is going to be a positive root 5 over 2 because I have 2 negatives. So this will be a positive 2 over root 5 for the cotangent. And then I need to rationalize it, and I get 2 root 5 over 5. I should have given myself more room on the notes. So we're going to do another example in just a moment. Over here, I need to find the 6 trig values. I have the tangent and I have the cosine. So for a space saver, I'm going to, over here, draw my 4 quadrants. I know the tangent is a positive, and I know the cosine is a negative, which indicates to me that the sine must also be a negative. So a negative over a negative gives me a positive. So sine is negative and cosine is negative. That puts me in the same quadrant, in the 3rd quadrant. I'm not going to label my tangent because that's not recommended. I am, however, going to label my cosine. Negative root 3, and then this is 2, adjacent over hypotenuse. I'm going to use the Pythagorean theorem. So I'm going to do negative root 3 squared plus b squared equals 2 squared. 3 plus b squared equals 4. So b squared equals 1, and b equals 1. This is a negative 1 due to its location. From here, I am going to now find all my other trig values. So sine is going to be negative 1 over 2, using opposite over hypotenuse. Cosecant would be the reciprocal of that, or negative 2. The reciprocal of cosine is secant, so that is going to be negative 2 over root 3, which is unacceptable, so I'm going to rationalize it by multiplying both by the square root of 3. So it's negative 2 root 3 over 3. I already have the tangent, so the cotangent will be the reciprocal of that, 3 over root 3, but I need to rationalize it, and I get 3 root 3 over 3, which furthermore can be simplified and to be just root 3. The next section of our notes is factoring using the fundamental identities. You might be like, well, I've never seen that. It's factoring. It's the same thing. It's just going to have tan in it, secant in it, etc. So when you use the trigonometric identities, rewrite if needed, usually getting down to sines and cosines. Tangents usually aren't nice. Sometimes they are, sometimes they aren't. And then we'll factor. Remember, the factoring methods are greatest common factor, difference of squares, sum of cubes, difference of cubes, trinomials, and grouping. So let's take a look at this problem first. 2 cotangent squared plus 3 cosecant x. No clue what to do. So I'm going to get it down to sines and cosines. 2, cotangent is cosine over sine, so 2 cosine squared over sine squared, plus 3, remember cosecant is sine, reciprocal sine, 3 over sine. Wow, looks like I have a GCF. So I'll pull out a 1 over sine, which leaves me with 2 cosine squared over sine, plus 3 over 1, or just plain 3. Still looks gross, but that's okay. Second one, this one screams something to me. It screams the difference of squares. So I would do tan x minus secant x times tan x plus secant x. Then the next one, as I pull down the screen just slightly for you and erase. This one down in the corner looks like a trinomial to me, so I will make a empty box thing, and I have 3 sine squared x in this corner, and I have negative 8 in this corner. So I know I need a 3 sine x, and I know I need a sine x. I need the 2 boxes here to add to negative 2 sine, so I'm going to try 4 and 2, but I'm going to make a 4 here and a 2 here. This will give me 4 sine x and 6 sine x. To get a negative 2, this would have to be a negative 6 and a positive 4. Then I get sine x minus 2 times 3 sine x plus 4. And I successfully factored my trigonometric functions. And you have finished your notes.